Alright, so a soft drink manufacturer surveyed consumer preferences for 7 names for its soda: J, K, L, M, N, O, and P. The manufacturer ranked the 7 names according to the number of votes that they got. The name that had the most votes was ranked first, and each name received a different number of votes. So we have the names, and since they each got a different number of votes, we're ranking them 1st through 7th. So now, let's go to rule number 1. J received more votes than O. So that means that O cannot be ranked first and J can't be ranked last. Rule number 2, O received more votes than K. So that means K cannot be ranked first and O can't be ranked last. Rule number 3, K received more votes than M. So that means M can't be ranked first and K can't be ranked last. Rule number 4, N did not receive the fewest votes. So we know that N is not last. Rule number 5, P received fewer votes than L, but more votes than N and more votes than O. So that tells us that N can't be first or second. We already know O can't be first, but we also know O can't be second now. We know P can't be first, and P can't be 6th or 7th. And we know L can't be 5th, 6th, or 7th. Okay, so let's create a long chain connecting our rules. So we know from rule number 5 that L is going to be before P, and P is going to be before N and O. We know from rule number 1 that J is before O. We know from rule number 2 that O is before K. And we know from rule number 3 that K is going to have more votes than M, so K is going to be before M. So, since we have, in the first option, 5 out of 7 eliminated, we know the only names that could have gotten the most votes are either J or L. Likewise, since for last place we have 6 out of the 7 eliminated, we definitely know that last place is going to be M. Alright, so we have the setup, rules, and our deductions. Let's go ahead and hit the next question.